Okay, so now I am going to teach you how can you find the runtime complexity of recursive algorithms. What are recursive algorithms? Recursive algorithms are those algorithms which give a call to itself. For example, let's talk about factorial. What is factorial? Factorial is the product of first n natural, factorial of n will be the product of the first n natural number. For example, if you have to find factorial of 4. So, factorial of 4 will be 4 into 3 into 2 into 1. Now, this you could write as 4 into factorial of 3, because factorial of 3 is 3 into 2 into 1. Now, factorial of 3 you could write as 3 into factorial of 2, because factorial of 2 is 2 into 1. Factorial of 2 you can write it as 2 into factorial of 1. Now, factorial of 1 is 1. Okay, the factorial of 1 is 1. So, when you multiply 2 into factorial of 1, you will get the value of this much, this expression, and you can substitute to return this value over here. Then whatever value you receive over here, you multiply it by 3, and the value calculated over here will be returned. Now, you multiply this value, the value that has been returned from here to here, multiply it by 4, and now what you have is the factorial of 4. So, what I want to tell you here, that factorial of 4 could be thought of as factorial of 4 into 3 factorial. Means that factorial of any number n, could be is factorial of n into n minus 1. So, if you have to write a program, or let us say an algorithm for finding the factorial of n. So, how you could write? You could say, okay, let's factorial of n, if n is equal to 1, return 1. If n is not equal to 1, you will return the value of n into factorial of n minus 1. Now, you are giving a call to factorial of n minus 1, the factorial of n minus 1 will be calculated, it will be multiplied with 1. How you will calculate factorial of n minus 1? You will again follow the same procedure, and you will go on doing it till the value of this becomes 1. When n is equal to 1, when n is equal to 1, you will return 1. So, this is here I was actually trying to explain you the concept of recursive algorithms. What are recursive algorithms? But our objective over here in this lecture, my objective in this lecture is to focus on how to calculate the run time of a recursive algorithm. Okay. So, for calculating the run time of recursive algorithm, let us see how we do it. Now, for this particular step, let us say if n is equal to 1, we can say that this is taking some constant amount of time, because this is not dependent on the input size n, this one single step. For this step, we could also say that this is taking some constant time n. But look at this step. How will you write the amount of time in terms of the input size or as a constant taken by this step? Because this is n into factorial of n minus 1, and we still do not know the run time, or we still do not have any expression for any way of expressing the run time of this factorial of n minus 1, because what we are doing here is calculating the run time of this algorithm which we have named as factorial, and here it is making a call to itself with a different input size, but we do not have yet know what is the runtime complexity of the algorithm factorial in terms of the input size. So, how can we write the amount of time taken by this step? It is very difficult. So, what we do, we write recurrence relation. Recurrence relation, we write it in form of an equation, and then we try to solve that equation to find the run time of such algorithms. How we write such recurrence equation? Look, we can say the time taken by this algorithm on an input of size n is equal to some constant c. This is also a constant, this is also a constant, so c plus c is 2c, but that is also a constant, so I am summing up all the constant involved with this c. So Tn is equal to some constant c plus the time taken for the same algorithm to run on this input size. This whole problem we have of finding the runtime of this recursive algorithm, we can represent the runtime of this recursive algorithm in form of this equation. The time taken to by this algorithm on input of size n is some constant plus the time taken by this algorithm on input of size n minus 1. Now we do not know what is Tn and what is Tn minus 1. So what we have to do, we have to come up with some means so that we could solve this recurrence equation. Now because it is a recurrence relation, it is an equation, we can solve it mathematically. So let me try to solve this one for you. Okay. So what will be Tn minus 1? Tn minus 1 will be c plus Tn minus 2, right? Tn minus 1 will be c plus Tn minus 2. So we can substitute this value of Tn minus 1. What will be? It could be Tn plus is equal to c plus T of n minus 2, right? Now what is t time taken by n minus 2? You could say, okay, some constant c, again some c plus t of n minus 3. Now look, if you look carefully at our problem, at this algorithm, how many times do you think we will be adding c's? C plus c plus c, Tn minus 1, Tn minus 2, Tn minus 3. It will go like this, c plus c plus c plus some number of c's, t of n minus, because here at n is equal to 1 we are returning 1. So at n is equal to 1 we are returning 1. So it will be t of n minus 1. Okay, t of n minus 1. Okay, we can write it like this. So how many c's you are going to have here? We'll have c plus c plus c plus another c over here. This will also turn into c. So how many c's do you think you're going to have over here? How many times this c will be added? It will be n into c. Okay. So this will be, you can say that the runtime complexity of this one is theta n, because we tend to ignore the constant c in our asymptotic analysis. So we can say that the runtime complexity of this recursive algorithm factorial is theta n.